Hello, it is Friday, April 10th, even though this lesson will cover Friday, April 10th and Monday, April 13th. We are going to find compound volume by adding the volumes together and find displaced volume by making a cross-section and subtracting the volume. So let's talk about what compound volume is. So there's a reason you see my wonderful face this morning, because I want to show you something. So, no, let's start with this. If I want to find the volume of this Star Wars lunchbox, well, what shape is it? Well, it's not a single three-dimensional shape. It's actually a shape that's made up of multiple shapes. I see a rectangular prism on the bottom. And then above the rectangular prism, I see a half of a cylinder. So remember, volume is the amount of space that something takes up. So if I want to find out how much space this entire thing takes up, I'm going to have to find the amount of space that the bottom, the rectangular prism, makes up. I'm going to have to find the amount of space that the half cylinder takes up, and the amount of space that the entire thing takes up would be the rectangular prism plus the half cylinder. So that's why compound volume, volume of multiple shapes. To find that, we are again adding the volumes together by adding the volumes together. So let's take a look at a couple of examples. So this is on your compound and displaced volume worksheet, which is in your volumes and three-dimensional objects packet. I want to find the volume of this shape. Well, what shape makes up these shapes, this big shape? I see two shapes. I see a cone, and then I see on top of that a hemisphere. So we go to our reference sheet. The cone is 1/3 pi r squared h. Because the hemisphere, it's half of a sphere, so it's half of 4/3 pi r cubed. Let me just pull up the calculator. Oh, you know what? I might lose that. That would be a shame. Good, it's still there. All right, so the radius of the cone is half of the diameter, which would be half of 8.3 is 4.15. The height of the cone is 10.2. And then the hemisphere, the radius is also 4.15. So because it says around to the nearest 10th, I believe, I'm going to type it into the calculator. So it's 1/3 pi 4.15 squared times 10.2. Let's hope I can remember that. 1/3 pi 4.15 squared 10.2. I get 183 whatever. Then I'm going to type in the hemisphere, 1/2 4/3 pi 4.15 cubed. So I've got 183 dot 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 149 dot dot dot. One 83 dot 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 149 dot dot dot. So again, if I want to find the volume of the whole cone, the whole thing, the amount of space the whole thing takes up, I'm going to take the volume of each shape and add them together. And remember we talked about don't round until the very end. So I'm going to copy and paste that. I'm going to copy and paste that. And now I can round it to the nearest 10th, 333.7. So that's compound volume. Compound volume is a shape made of multiple shapes. Find the volume of each shape, add them together. Let's try one more. Let's try number 3. So the question is, what shape makes up this shape? Well, this shape's actually very similar to my lunchbox because it's essentially the same shapes. It is a rectangular prism on bottom. And then it is a half cylinder on top. So if I go to my reference sheet, rectangular prism is length times width times height. Half cylinder is half of a cylinder, which is pi r squared h. Again, you're not going to see this formula on the reference sheet. You're going to see this formula because it's half of the cylinder. I just put a half in front. Only little twist here, my radius. Well, if this is 12, then this is 12, which makes my radius 6. And my height of my cylinder is the same thing there. It's a little bit hard to see. That's 25, that's 12, that's 8. I want you to try this on your own. I'll give you a little bit of a head start. I'll give you like a 2-minute head start. Find the volume of the rectangular prism, find the volume of the half cylinder, add them together. Again, I'm going to give you about 2 minutes right now to try it on your own, and I'll start up in a couple minutes. Just typing what I wrote onto my paper down. Again, because it says to round my answers, I'm typing pi in. In general, you're typing pi. Most of the time you're typing pi in, unless it says in terms of pi or it's multiple choice where pi is in your answers. 2400 and 1413. So the amount of space that this thing takes up is 2400. The amount of space that this thing takes up is 1413. So the total amount of space the whole thing takes up would be 2400 plus 1413. I'm just going to copy and paste the values in my calculator. And I get to the nearest tenth, 3813.7. So that's it for compound volume. Just find the volume of the individual shapes and then add them together. Which brings us to displaced volume. So that starts with number 5. So basically, what they're asking for number 5 is the amount of space. So let's say we have this thing, this little thing right here. We have a box and we have a pyramid inside of it. I want to know how much water or sand that I can fill inside that box. So basically, I'm asking you for the volume of the space inside the rectangular prism, but not inside the pyramid. Again, think of it as I want to pour sand in, or I want to pour water in, or I want to pour rice in. And how much of that can I pour in? Well, it would be the amount of space in the entire box minus, I'm taking away the volume or the space of that pyramid. So to find displaced volume, I'm going to subtract their volumes of the two shapes. So I have a rectangular prism. I have a pyramid. I can go to my reference sheet to get my volume formulas. 2 times 2 times 1, 1/3, 2 times 2 times 1. I don't need a calculator for that. I have 4 and I have 4/3. So to find the amount of space inside the box, but not inside the prism, well, I'm taking the amount of space that the box holds and I'm subtracting the amount from the pyramid. I feel like I might have just misspoke. I might have said prism, pyramid. I can use my calculator for that. I'm not going to pull up my calculator. To the nearest tenth, that is 4 minus 4/3, 2.7. Now, a very common extension of displaced volume is hollow objects. So in order for us to understand about hollow, ooh, my face is really close there. In order for us to understand about hollow objects, we're going to use a very important item right now, which is very hard to get based on what's going on in the world. Roll toilet paper. So let's say that I want to determine the volume of the toilet paper. Well, there's a little bit of an issue here because this thing is hollow. If I find the volume of this cylinder, that's not going to be accurate because I got this big space in the middle. So this is essentially displaced volume. So here's my question to you. How many shapes do you see right now? I don't see one shape, I see two shapes. I see the big cylinder, and then I see the cylinder inside. The cylinder that makes up the empty space. So if I want to find out the volume of just the toilet paper, just the white here, I'm going to have to find the volume of the big cylinder, the volume of the small cylinder, and then subtract them. I'm taking this volume, this cylinder's volume, out of the big cylinder. Hopefully that makes sense. Now to help you with this, I want you to draw what we call a cross section. We learned about cross sections a couple of days ago. Basically what you're looking at right now is the cross section. It's a two-dimensional slice of a three-dimensional object. It's kind of like a circle with a circle in the middle. So whenever you're dealing with hollow, I want you to draw a cross section. You're going to see that it's going to make it a little bit easier to find. And again, the concept, if I want to find the volume of the actual toilet paper itself, the volume of the white, I'm going to find the volume of the whole cylinder. I'm going to find the volume of that empty cylinder inside. I'm going to subtract that volume out of the big volume. So basically the volume of the big shape minus the volume of the small shape. And going back to what we said in our aim, I can find displaced volume by making a cross-section and subtracting the volumes. For the first example we did, we didn't need to make a cross-section, but now we are. So let's take a look at number 8. So we kind of have a cross-section already here. I don't really have to draw my own cross-section because, well, I kind of see my cross-section right here. So if I read through this thing, it says there's a solid metal rectangular prism, then there's a hole in the shape of a cylinder. So I have a rectangular prism, and I have a cylinder. So I'm going to find the volume of each. The volume of the rectangular prism is 4 times 4 times 6. The volume of the cylinder, well, the radius is 1. Now the height of the cylinder. If I go back to my toilet paper, what's the relationship between the height of the inner cylinder and the height of the outer cylinder? Well, it's the same height, correct? The big cylinder has this height, and if I pull out this tube inside, it's going to have the same height. So when I have a hollow shape, the heights of both shapes must be the same. So what is the height of this cylinder? It's 6. That's how high the cylinder, that's how deep the cylinder is. So I can use my calculator at this point. 4 times 4 times 6. 4 times 4 times 6. Pi times 1 squared times 6. So 96 and 18.85. I'll just write 18 dot dot dot. So again, the amount of space, the volume of this thing, the leftover solid that's not being taken out from the cylinder, I'm going to subtract them because I'm not adding them. I'm not adding the cylinder onto the rectangular prism. I'm taking that cylinder out. And if I go back to my calculator, I'm just going to copy and paste them. Again, I don't want to round until the very end. To the nearest tenth, that's 77.2. So again, I'm finding the volume of the hole shape, I'm finding the volume of the inside shape, and I'm subtracting them because my volume that's left is the remainder after that's taken out. All right, so let's take a look at something like number 11. And here's my paper towel roll, very similar to the toilet paper roll I just held up. Again, to make this easier, whenever you have a hollow shape, I want to see a cross section. So my cross section looks something like that. What two shapes am I dealing with here? I'm dealing with, again, just what I showed you with the toilet paper, 2 cylinders. So I'm going to say the big cylinder. And then I'm going to do the small cylinder. And again, whenever I have something hollow, the heights of the 2 cylinders are going to be the same. So it has a diameter of 8. So I'm going to show that on my cross section here. And the paper has a thickness of 3 inches. So what that means is, let's do a different color for this. Oops. That means that that's 3 and that's 3. That's what the thickness means. It means that from here to here is 3 and from here to here is 3. So my big cylinder has a diameter of 8 and the height is 12. My small cylinder has the same height, but take a look. This is the base of my small cylinder. What's the diameter of that? Well, if this whole thing is 8, and this is 3, and this is 3, then this in here must be 2, because 3 plus 2 plus 3 must equal 8. Basically, I have to subtract the thickness off of both sides. So this one has a diameter of 2. That's how you deal with the hollow shapes. Again, drawing a cross section will help you more clearly see what's going on. Whatever the thickness is, the thickness goes on both sides. You just subtract the thickness off of both sides to determine your inner diameter. So now I can just set up my volumes. My radius is 4 if my diameter is 8. My radius is 1 if my diameter is 2. Go to my calculator. Pi times 4 squared times 12. Pi times 1 squared times 12. Again, a hollow shape will always have the same height. So I have 603 and 37. And to find the space that's left, to find the volume of the actual paper towels, I'm going to subtract them. Again, I'm not adding them. I don't have 2 cylinders on top of each other. I'm pulling that one cylinder out of the other one. .603 minus 37. Again, we don't round to the very end. To the nearest tenth is 565.5. And that's cubic inches. So again, whenever you have something hollow, show me a cross section to make it a little bit easier on yourself. That'll help you get what your dimensions are of your inner shape. Find the volume of the outer, find the volume of the inner, and subtract them. I want to just set up one more for you just because I want you to see this whole cross section thing again. A hollow metal pipe is in the shape of a rectangular prism that has a height of 12. So I see not one rectangular prism, I see 2 rectangular prisms. So I'm going to write the big rect prism and the small rect prism. So when I draw my cross section, I'm not going to draw a circle, I'm going to draw a rectangle. I basically see my cross section right here. Looks something like that. The height of the rectangular prism is 12, so it might be helpful to draw these. To draw a rectangular prism, by the way, I would make a rectangle, then another rectangle, and connect them. I'm going to run out of space in this question. What else? So the height is 12. Again, the height of, in a hollow shape, the height of both the outer and the inner, the big and the small, are going to be the same. The length is 5 and the width is 2. So that's going to be 5. That's going to be 2. So for the big shape, it's 5 and 2. Now, if the thickness is 0.5, this is 0.5, this is 0.5, this is 0.5, and this is 0.5. So let's get another color here. This distance here is going to be 5 minus 0.5 minus 0.5, which is 4. I'm going to say that again. This distance here of this rectangle, this inner ring rectangle, is going to be 5 minus the thickness from both sides. Minus 0.5 minus 0.5 is 4. Now, let's do a new color. On this side, this whole, if I want to find this, This whole thing is 2. This thickness is 0.5. This thickness is 0.5. So I'm subtracting 0.5 twice from 2, which gives me 1. So my inner rectangular prism is 4 by 1. So now that I have that, length times width times height, 5 times 2 times 12, 4 times 1 times 12, that's 120, that's 48. From there, I subtract out the empty rectangular prism, and that's my answer. Again, the trickiest part, it's all happening here. That's why I want you to draw a cross section. Again, what did I do to come up with the 4? If this whole thing was 5, I'm subtracting 0.5 and 0.5 from 5. That gives me the 4. On this side, to come up with the 1, I'm subtracting 0.5 and 0.5 from 2. That's what gives me 1. That inner rectangle has dimensions 4 by 1. Once I have that, I transfer that information over to here. My heights of a hollow shape, of the outer shape and the inner shape, are going to always be the same. And then from there, just calculate my volumes and subtract them. Not an easy lesson, not super complicated, but it's definitely conceptual. And this is definitely the trickiest part. And yes, this is something they like to ask on the Regents. So to sum up, I can find compound volume when I have a shape made up of multiple shapes added on top of each other. I'm going to literally find each volume and add them together. I can find compound volume by adding the volumes together. I can find displaced volume by making a cross section and subtracting the volumes. All right, if I have to take an empty shape out of something, that's subtraction. Your classwork/homework is to finish compound and displaced volume. Again, this is in your volume and 3-dimensional shapes packet, which I sent you on Remind, Google Classroom, and is on Schlansky.com. And then your quiz, you know what? It's a 2-day lesson, so you're gonna basically do half today, do half it on Monday. So I'm gonna say the quiz is gonna be due on Monday. That's it. Any questions, hit me up on Reminds, and enjoy your weekend.